Hello everyone, this is Helen Sathiya, Assistant Professor in the Department of Computer Science and Engineering from V.Helen Multitech Engineering College. A process is basically a program in execution. When a program is loaded into the memory and it becomes a process, it can be divided into 4 sections: stack, keep, text and data. We write our computer program in a text file, and when we execute this program, it becomes a process which performs all the tasks mentioned in the program. The stack section contains the temporary data such as method, functions, parameters, return address and local variables. The keep section contains dynamically allocated memory to a process during its runtime. The text includes the current activity represented by the value of program counter and the contents of the processor's register. The data section contains the global and static variables. Process scheduling is an essential part of multi-programming operating systems. Such operating systems allow more than one process to be loaded into the executable memory at a time. The operating system maintains the following process scheduling queues. First one, job queue. Second one, ready queue. Third one, device queue. Job queue. This queue keeps all the processes in the system. Ready queue. This queue keeps a set of all processes residing in main memory, ready and waiting to execute. Device queue. The processes which are blocked due to unavailability of an input-output device constitute this queue. This is the block diagram of process scheduling. This is job queue, this is ready queue, then this is input-output waiting queue. Schedulers are special system software that handle process scheduling in various ways. Schedulers are of 3 types. First one is long-term scheduler, second one is short-term scheduler, third one is medium-term scheduler. Long-term scheduler, it is also called a job scheduler. It also controls the degree of multi-programming. If the degree of multi-programming is stable, then the average rate of process creation must be equal to the average departure rate of processes leaving the system. Second type scheduler is short-term scheduler. It is also called as CPU scheduler. CPU scheduler select a processes among the processes that are ready to execute and allocate CPU to one of them. Short-term schedulers are also known as dispatchers. Short-term schedulers are faster than long-term schedulers. Third one is medium-term scheduler. Medium-term scheduling is a part of swapping. It removes the processes from the memory. A running process may become suspended if it makes an input-output request. A suspended process cannot make any progress towards completion. In this condition, to remove the process from memory and make a space for other processes, the suspended processes is moved to the secondary storage. This process is called swapping. And the process is said to be swapped out or rolled out. Operation on processes. Operation on processes involves various operations: ready, running, waiting and terminations. Creation. This is the initial step of process execution activity. Some of the such events are following. When we start the computer, system creates several background processes. A user may request to create a new process. A process can create a new process itself while executing. Batch system takes initiation of a batch job. Second one is scheduling and the dispatching. Dispatching is done by operating system when the resources are free or the process has higher priority than the ongoing process. There are various other cases in which the process in running state is preempted and the process in ready state is dispatched by the operating system. Blocking. Black mode is basically a mode where process waits for input-output. Hence, on the demand of process itself, operating system blocks the process and dispatches another process to the processor. Preemption. When a timeout occurs, that means the process has not been terminated in the allotted time interval and next process is ready to execute. Then the operating system preempts the process. This operation is only valid where CPU scheduling support preemption. Fifth one is termination. Process termination is the activity of ending the process. Process termination is the relaxation of computer resources taken by the process for the execution. Inter-process communication. Inter-process communication is a mechanism that allows processes to communicate with each other and synchronize their actions. The process can be of two types. First one is independent process. Second one is cooperating process. An independent process is not affected by the execution of other processes, while a cooperating process can be affected by other executing processes. The communication between these processes can be seen as a method of cooperation between them. The inter-process communication method are two types. One is shared memory, another one is message passing. An operating system can implement both methods of communication. Communication between processes using shared memory requires processes to share some variables and it completely depends on how the programmer will implement it. This is the block diagram of shared memory and message passing. First block diagram, shared memory. Suppose process 1 and process 2 are executing simultaneously and they share some resources or use some information from another process. Process 1 generates information about certain computations or resources being used and keeps it as a record in shared memory. When process 2 needs to use the shared information, it will check in the record stored in shared memory and take note of the information generated by process 1 and act accordingly. This is the message passing method. In this method, processes communicate with each other without using any kind of shared memory. If two processes P1 and P2 want to communicate with each other, start exchanging messages using basic primitives. We need at least two primitives. One is send, another one is receive. The message passing method have two parts. First one is header part, another one is body part. The header part is used for storing message type, destination ID, source ID, message length and control information. The control information contains information like what to do if runs out of buffer space, sequence number, priority. Generally message is sent using FIFO style. Thank you.